Hey guys, welcome to the Pre-algebra 6.7 video where we're talking all about probability and odds. So probability and odds, very, very important because it's something that you're going to encounter every day, right? What's the probability that this thing's going to happen? Should I get on this plane? Should I buy this car? Because what's the probability I'm going to have engine trouble? Should I invest in this stock? Should I send my kid to this school? Right? So incredibly, incredibly important. And so before we get into it, let's talk about some definitions. All right, outcomes. Outcomes are just the possible result of an experiment. Now, I don't mean like a chemistry experiment. I mean rolling a die. Okay, six-sided die. There are a lot of outcomes there. An event is a single outcome or a collection of outcomes. A favorable outcome, well, it's kind of hard to quote define, so I'm just going to give you an example. So the favorable outcomes for rolling an odd number on a six-sided die would be rolling 1, 3, or 5. Those are favorable because if you're trying to roll an odd, if you roll 1, 3, or 5, you will get what you wanted, right? It's in your favor. And the probability is just a measure of the likelihood that an event will occur. So let's get into probability a little bit more and finding the probability. Okay, so the probability of any event, okay, well, that can be found by taking the number of favorable outcomes divided by the number of possible outcomes. So let's take some die, and we're actually just going to work with one for the moment. Okay, so we have one die in our hand, and we want to find what's the probability of rolling a 1. Well, the number of favorable outcomes, if we want to roll a 1, would be 1. There's only one number 1 on the die, so there's only one of those things that we could roll on that would get us what we want. But we have to divide that by the number of possible outcomes. Well, when I roll a die, I could get a 1, but I could get a 2, a 3, a 4, and a 5, and a 6. So there's 6 possible. So what's the probability of rolling a 1? In this case, we don't need to simplify this fraction anymore. It's 1 over 6. Or, as a percent, how would you find that? Well, you take 1 divided by 6 to get your decimal first, right, which would be 0.16 repeating, and to make that decimal a percent, you would move the decimal 2 places to the right, and you'd have 16.6 repeating percent, or you could round it up to 16.7%, okay? So now let's talk about the probability of rolling an even number. Well, how many favorable outcomes would there be? Well, on a die, there are, let's see, first even number would be a 2, then a 4, then a 6. So do we put 2 plus 4 plus 6 up there or anything like that? No, because we want the number of favorable outcomes. So how many even outcomes are on a die? Well, there's 3, a 2, a 4, and a 6. And we divide that by the number of possible outcomes. Again, we're talking about a die, so we have 6 sides. So now I need to just simplify this to 1 over 2. Okay, and that would be the probability of rolling an even number. You could also say 50% or 0.5. So real quick before we move on, why don't you take a second and solve this one? What is the probability of rolling a number greater than 4? Well, how many favorable outcomes are there? Well, we want a number that's greater than 4. So we have on a die a 5 and a 6. So there's 2 favorable outcomes, and there are on a die there's 6 possible. So we get 2 out of 6 or 1 out of 3. Okay, 1/3. All right, so next let's talk about experimental probability. Okay, so experimental probability is very simple. It's just the number of successes divided by the number of trials. Now, it doesn't only have to do with such things as chemistry, but that is one way you can think about it for sure. Right? So let's say some chemist is trying to make some kind of crazy compound, right? And they tried to make this compound 500 different times, okay? And they only got the compound to work, though, let's say 35 times. So what's the experimental probability here? Well, how many successes did they have? Well, 35, okay? How many trials? 500. So if you take 35 over 500 and simplify that fraction or divide, you would get 0.07, okay, or it would 0.07 would of course be 7 over 100, all right. So you could do it that way. Really, if you do a decimal, this should give me a percent, which that would of course be 7%. Oops, 7%, not 70. So 7% or a 7 out of 100 probability. All right, so I want you to go ahead and take a second and try this one. Pause the video and solve it when play the video when you're done solving. All right, so last week, 255 golfers visited Martin's Mini Golf. 45 of the patrons made a hole in one on number 17. So what we want to find is the probability that a golfer will make a hole in one on number 17. So again, experimental probability on top, we have the number of, what do we have up here? Successes, all right? And then on bottom, we have the number of trials, so successes. How many hole-in-ones were there? 45. How many trials? Well, in this case, it was all the numbers of people who went through on number 17, right? And it was 255 people. So 45 of those 255 got a hole-in-one. And if you find that as a decimal, you get 0.17647, so on and so forth. So let's just take that and let's round that to 0.18. Okay, so there's a 0.18 probability that a golfer is going to make a hole-in-one on number 17. So before we keep moving, let's just cover range of probability. Range of probability is just saying that, you know what, probability can actually only range as a decimal from 0 to 1. Okay, now the probability of something, or if something has a 0 probability, we actually call that impossible. Okay, therefore something would be impossible to occur. Now this would also be the same as 0% chance. Now 1, on the other hand, is actually 100% as a, the number 1 as a percent is 100%, and it means it is certain to occur. So if you calculate the probability of something and you get 1 as your number, well, then you can be absolutely certain the next time it happens that it is going to happen, all right, that the favorable outcome will occur. So for example, if 255 of these golfers went through and all 255 got a hole-in-one, you would take 255, which is the desired outcome, over the total possible 255, which would be 1. Okay, and therefore you would say that the probability the next person goes up that they're going to get a hole-in-one is certain. So let's use some probability to predict. Okay, so you're practicing your free throws. You attempted 50 and you made 32. Now what we want to do is use experimental probability to predict how many you will make if you shoot 75. Okay, so let's take this experimental probability right here. Right, you're experimenting technically with your free throws. You shot 32. You shot 50. You only made 32. So your probability of making them is a 32 out of 50. Okay, so 32 out of 50. We could simplify that fraction down. Divide by 2. You would get 16 out of 25, and if we're going to leave it in fraction form, we would just leave it, okay? Now, if you really wanted to, you could take 16 divided by 25, and you get 0.64, okay? But for our purposes, this is probably going to be the form we want. Now, if you make 16 out of 25, well, let's use experimental probability to predict how many you will make if you shoot 75. So we need to actually think back to last year and about ratios, all right? And proportions. So what I'm going to do is I'm going to set up a proportion, and that is 16 out of 25. Okay, so this is the same as saying 32 out of 50, 16 out of 25, which would be 32 was the number we shot, or I'm sorry, the number we made, okay, over what used to be 50, now is 25, and 50 was the number we shot. And we know, because we're using probability to predict, that this fraction is going to equal another fraction. The bottom of this fraction is going to be our new experiment and the number of trials, which will be 75. If I shoot 75, though, how many will I make? Well, I don't know, so that's what we need to calculate. That's our variable. Now, this one we can actually do using mental math, because I know if I take 25 times 3, I'll get 75. So all I need to do is take 16 times 3. And when you take 16 times 3, what you end up getting is x equaling 48. Okay, so what do we know now? Well, we know that if you shoot 75, you are likely to make 48. Now, you might make less, you might make more, but given your experiment of shooting 50 and making 32, we can, with some confidence, say that if you shoot 75, you're going to make 48. So the next thing we'll talk about is odds in favor and odds against. Now, unfortunately, this is used a lot in gambling. So better to, I guess, understand it so that way you can recognize when things are, really shady and you shouldn't gamble, because the odds in favor are usually in favor of the house and not you. So let's understand their terminology so that you can make better decisions, which would primarily be not to gamble at all. Anyway, so let's talk about odds in favor and then odds against. So let's use this little situation here. We're going to pick a number between 1 and 20. And we want to find what are the odds in favor of picking a prime number. Okay, so when it comes to odds in favor, you have favorable over unfavorable. Okay, so favorable outcomes. What would be a favorable outcome in this situation? Well, the odds in favor of picking a prime number. So prime numbers are favorable. So what are the prime numbers between 1 and 20? So let's see, 2, 3, 5, 7, 11, 13, 17, and 19. Okay, so how many prime numbers are there? 1, 2, 3, 4, 5, 6, 7, 8 prime numbers between 1 and 20. So if there are 8 favorable outcomes between 1 and 20, well, how many unfavorable are there? Well, unfavorable in this situation would be numbers between 1 and 20 that are not prime. So 4, 8, 12, 15, right? So if we count the other ones, you'd have 1, 4, 6, 8, 9, 10, 12, 14, 15, 16, 18, 20. So there should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 unfavorable outcomes. Okay, so what are the odds in favor? Well, they're 8 out of 12, and we would simplify this down to 2 over 3. Now, when it comes to odds, we read it not something over something, but something to something. Okay, so instead of 2 over 3, we'd say the odds in favor of picking a number between 1 and 20 and it being prime are 2 to 3. So if you want to pick a prime number between 1 and 20, you would look at these set of odds and say, okay, well, which number is greater? Well, 3. So it's more likely you'll pick something that's unfavorable or not prime than you will pick that something that is prime. Now, another cool thing about odds is when you think about the number of possible outcomes. Okay, so picking a number between 1 and 20. So you could pick a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, up to 20, right? There are 20 total outcomes. So if you count the favorable and the unfavorable, well, 8 plus 12 gets you 20. The favorable plus the unfavorable will give you the total. So what are the odds against? Well, the odds against in this situation, or really in any situation, would be unfavorable on top over favorable. Okay, so using the same situation, okay, let's think about unfavorable outcomes. Well, I want to pick a number that's prime between 1 and 20. Okay, so unfavorable would be picking something that isn't what I'm looking for, so not prime. Now there are 12 not prime numbers between 1 and 20, and there are 8 that are favorable or are prime. So the odds against, we would simplify that down as well, would be 3 over 2, but again we read that 3 to 2 against. Okay? Alright guys, that is all I have for you. I look forward to seeing you in class and talking more about probability and odds.